In this video, I'm going to demonstrate Soundscape synthesis through feature extraction and Modal-Granular synthesis. Since the MATLAB code takes a long time to run, I will first start the MATLAB code while I'm explaining my script. So as you can see, MATLAB is analyzing the soundscape. It generated 2000 grains and so forth. So I'm using a soundscape which was recorded in Brooklyn, and I only use the first 30 seconds of the recordings. So my algorithms will first perform a multi-band analysis on the recording. So I use 3 mel-band filters to create a low band, mid band, and high band of the original recordings. These 3 bands are used for basically for segmentation, which creates some segments on each band, and they're stored in the structure, as you can see on line 38 to line 46. After we get the segments, we start to extract more details from the segments. So we do the second mel-band analysis. So finally, we should able to get the number of grains is equals to 16 times the number of segments in the signals. So that's why we got like 2000 grains here. The below's code extracts 16 subband from each segment, and the subbands are also mel-bands. I do the same thing for each segment. Here you can see I also use mel-band analysis. But the bandwidth and the range is much smaller than the wideband mel-band analysis, which is for the wideband this is about 4000 mel frequency, which is a really wide bandpass filter. But for here, for the segments, I only use 500. So after analysis, we got a spectrum matrix from the mel-band analysis, and the matrix is passed to modal analysis, which gives me some peak frequency and envelopes. And the envelopes is used for as well. The envelopes and the peak frequency are used for generating some samples, which is stored in the modal output. These are the grains for generating soundscape. As you can see, MATLAB is already generating some soundscape. So mid-band and high band is basically the same as the lower band, except the range is different because the frequency content is different. So the range of mel analysis is slightly different. So after that, we compute the spectral envelopes of the original soundscape. As we want to maintain the spectral envelopes of the original soundscape, I decided to compute the spectral envelope and use the spectral envelopes as random distribution for granular synthesis. So each spectral envelope is actually summed to 1. So after we get the spectral envelope, we have the modal output, which is the samples, and we generate 60 seconds of soundscape. The hop size is 64 samples, and each frame has about 3 samples, which is which will the sample per frame will be changed every frame in this while loop. As you can see, the random density is controlled by random numbers here. So, and MATLAB is generating the soundscape. Now MATLAB has generated the soundscape, and we can see the plot of the soundscape. Thank you for watching.